Okay, this is in a the objective in this video is to answer the question, what does acceleration tell you about an object, and be able to explain the difference between these things. So let's take a look at what we're dealing with. So the title of this, in case you're doing this for the first time, is When Speed Changes. It's on page 29, and this is topic number 10 in your gradebook. The definition of the acceleration is the net change in an object's velocity during a specific amount of time. Or these formulas. Remember, formulas get highlighted in green. There's the bell. Don't be tardy. Formulas get highlighted in green. Acceleration is change in velocity over change in time. Or anytime we see change, it means final minus initial over time. Technically, time is the same thing, but when we start observing things, time equals 0. So t final, 11 seconds, is, well, the same as just, we'll call time 11 seconds. We tend to not distinguish between that one, just because that's how we roll. When you graph it, it's a velocity over time graph, because acceleration equals velocity over time. Slope is the rise over the run. Velocity over time. Slope tells us acceleration. Okay, the example from our lab that we did last week was we were watching this ball drop and kind of plotting its movement. And if you were the person doing the buttons on the iPad, the ball drops and it doesn't go very far, and it's kind of really hard to find out where it is because it almost looks like the ball's not moving. But then it starts to fall farther and farther and farther and farther each second. So this change in distance as it falls that you can observe here is acceleration specifically. It's increasing its velocity. More specifically, let's look at this. Here is one of your test questions. What does acceleration tell you about an object? You might want to write this down if you haven't already. If you're just reviewing, acceleration tells us how velocity changes. And then what does it mean if an object has blank acceleration in meters per second squared? Because the units of acceleration are meters per second squared. So let's talk about what that means. Let's take a look at this bunny. In the first second, it moves 2 meters in 1 second. In the next second, it moves 4. And in the next second, it's moving 6. So this is back what I mean right here. We're observing a change in velocity. More importantly than that, we have this predictable change. It's going +2 every time. I would predict that in the next second it would be going 8. So here's what we're looking at. Velocity over time is meters per second over seconds. And if you remember in fractions, if you have a little fraction over a big one, you can take this denominator and make it meters over seconds times seconds, or meters per second squared. In other words, what does it mean if an object has an acceleration of 2 meters per second squared? That means it's going 2 meters per second faster every second. 2 meters per second faster every second. It's speeding up. This could just as easily be on your test, what does it mean if acceleration is -2? Well, that means it's going 2 meters per second slower each second. Now let's do this example. I showed this movie, and sorry, that was too loud for you guys probably. Don't drive fast, but it does make for a good physics problem. We watched a person accelerate. You could tell it was accelerating because the speedometer here was moving. We are going to call this speed our initial velocity. Velocity initial equals 60 kilometers, so we'll call it 16. Sorry, I was supposed to stop it right there. 16.6 meters per second. Velocity final was at 240. These are kilometers per hour, so 240 is the same as 66.6 meters per second. And time when we timed it in class was 12 seconds. So acceleration equals v final minus v initial over time. So this is an example of we started observing it when it was going this fast, and we ended observing it when it was going this fast. Final 66.6 minus 16.6 divided by 12, 50 divided by 12. This is something like 4.16 meters per second each second. He's on average going that much faster every second. So that's kind of an example of how the formulas work. The last thing, just some kind of visual examples. We'll skip the graph. Positive acceleration means an object speeding up. We've already looked at this. This bunny's going kind of fast, and then faster, and then really fast. So positive acceleration when velocity increases is an acceptable definition if I were to ask you about that on a test. Negative acceleration is an object slowing down. And finally, zero acceleration is no change in velocity at all. This is going constant speed. Or it's not moving, it's stationary. Sleeping turtle with a nightcap on. So that's our acceleration intro. The next video, topic number 11, will be our intro to new formulas.